This is the third booklet I produced for my granddaughter, revision. It's just for revision, really. She should have done all this already, just to help her in the exam next year. Again, you may not want to copy this. If you do, you can use, as I said before, the snip function, which is Shift Windows key S. I'll just go through it again. Shift Windows key S, and you can highlight areas you want to copy, and it's copied to the clipboard. You can copy 25 pages this way using Shift key S. They go to the clipboard in an order so that when you come to put them back, you have to start at the bottom and work up. If you try to use the ordinary copy function, it's no good, because that just puts one piece on the clipboard. The next time you copy it, overwrites it. This one copies 25 pages sequentially. So if you want to copy it, you can do, and make your own booklet. If not, just look it on here and pause it whenever you want to. I'll leave the pages on as long as I can. But you can read this, my idea of probability statistics. You may not like it, but see what you think anyway. There's some examples of probability. Again, I'll leave it on. You can either read it or copy it using Shift key S. When you're reading this, if you see something I've done wrong, or made a mistake, and please don't hesitate to tell me. Nobody's perfect, and I make mistakes just like anybody else does. I think you should have read that by now, so let's look at the next page. From that previous page, it shows you that 15% like grapes. You can use a bar chart like this. As I point out here, the statistics can be used to fool people. If you draw a graph, change the scales, it makes it look really good because the scale is too large. Make it correct, and you see that it's not quite so good as it looks. Okay, next page. As it said, Benjamin Disraeli said, there are lies, damn lies, and statistics. Just a little problem for you there to draw a line between the things. One of them was obviously you will develop X-ray vision. This is obviously impossible. Oh, is it? Maybe? I don't know. Okay. Next page. The values are, again, mean, median, and mode. You've probably, all of this is just revision. So this has already been done before. Just a bit of talk about mediums, that sort of thing. Just help refresh your memory, I hope. This just refreshes a memory on stem and leaf diagrams. A problem to show you. Can you see what's missing? There's something missing. Sometimes you get questions like this in the exam. They show you a leaf diagram and say, point out the errors. Left the page on quite a while. If it's not enough, you can always pause the video. Okay, that's back to probability. That's what it's all about, really. But there are quite a few problems in probability on the exam papers. Most of them are reasonably straightforward. Of course, we're just looking at the very bare bones of probability. If you were to go into the real mathematics of probability, it becomes quite daunting, unless you're a mathematician, of course. These are the basic probability formula. Most of the time we don't use all of them, but here we are. Further down. Now I've got some examples. Of course, that's what we do in the exam, is the examples, isn't it? So if you look at these examples, you can see where what's being used. Besides these three booklets, I've produced a couple more booklets on the past exam questions. So I've taken 50 from one board and 20 from another, and I've put down the actual solutions step by step, so they should be able to follow them. And you'll probably see that there are, on each paper, there are maybe one or two probability questions. Another question here. Use this symbol here, but not red, a little dash. These symbols, you've seen before probably, or and. This was a difficult question, of course. You have to draw a Venn diagram, first of all, and then work out the probability of these two things. Not an easy question, but actually from an exam paper. In fact, it's probably in my 50 questions somewhere. There's another question. These are tree diagrams. There's usually a question on tree diagrams in the exam. and this shows the actual tree diagram. Get the same answer, 0.455. Finally, we've got this one here. The tree diagrams are quite useful. This one, I take this from a book, Probability for Dummies, by Deborah Rumsey. It's a good book, but very complicated. A bit too complicated for the GCSE higher grade. It'd be okay if you were doing A levels. And it shows you a true life series about pizzas. If you buy a pizza, you can buy either small or medium or large. It can be thick, thin, or thin thing. You can either have a pepperoni and mushrooms, or just pepperoni without mushrooms, or just the mushrooms. So we've got the pizza size there, SML, crust is thin or thick, pepperoni R or not R, and mushrooms or not mushrooms. The diagram I put on the next page because I copied this from a book, and of course it wasn't easy to copy. So you have to give credit to Deborah for this, not me. There you can see the top line there. It goes from there to there to there. So you've got different sorts of things. Okay. So that's how it shows in the book. Now what I've done on the next page is a little problem for you to solve using that tree diagram. Put these numbers in, work out the probability of people who like a medium thin pizza with pepperoni but no mushrooms. That's what they do. I mean, if you're in industry, you want to know what pizzas are best served. There's no good making a pizza when only 1 in 15 people eats it. So that's probability. But again, you can either copy the pages, which is if you want to, or you could just go through the video and pause. But if you're interested, I have 2 other ones, one on circle diagrams, circle theorems, sorry, and one on triangles. Both revision booklets and for people who've already done the courses and are just revising for an exam. Hopefully I'm going to put the 50 exam questions on. You probably wouldn't want to copy them because it takes a lot of paper. But I'll put them on, you can look through them when I put them on. Thanks for watching.